Okay, so over the course of Thanksgiving, I tried to give myself a little break and unplug from the whole flat Earth stuff for a while. I say tried to take a break because I wasn't watching any videos or going online or anything, but you still can't avoid things like going outside and seeing the moon. And there was a almost full moon last week, and every time I go outside and see that and stand in the light of the full moon and see my shadow being cast on the ground, it still just amazes me now, because just how much light it would actually require to supposedly bounce from the sun off of the moon and cast a shadow um, on the ground in the middle of the night, uh, which is just crazy to me, because when you think about how bright the surface of the moon would actually have to be when you got that close to it, then personally I don't see how there would even be any like shadows on the moon at all, in terms of the footage of the lunar landers and everything, the astronauts. Even the underside of everything should be completely lit up, right? If it's reflecting that much light, it'd be like walking around on a giant glow stick or something. But anyways, that's not what I came to talk about. But so I started going back and doing some more reading on the moon and moon phases, and that was something that, when I was first looking into the flat Earth issue, was hugely impactful to me, because there's just so much about the phases of the moon and seeing the moon during the day and all the angles and everything. There's just so much weirdness in there. So if you're looking at it for the first time, that's definitely a good place to start. It's just, on your own, going and looking at what all the official explanations of the lunar cycle is, and then comparing that to what you see in the sky yourself, and seeing how much sense it makes. So I was just reading through all that again, and I stumbled across this concept of Earthshine, which I had never actually heard about before. At least I'd never paid attention to it, if I have. And maybe a lot of you are already familiar with this, but it was kind of new to me. And so I was really surprised that there was nobody. I couldn't find any videos talking about Earthshine in relation to flat Earth. That kind of surprised me. Maybe they're out there, I just didn't see them. But it's just another one of these really bizarre little bits of information that, when you really stop and look at it, is just so bizarre. So basically, what Earthshine is the explanation, the official explanation given as to why, when the moon is in a crescent phase, like the few days before the new moon and the few days following the new moon, when you just have a sliver of a crescent, why a lot of the time you can actually see what is supposedly the shadow side of the moon, the part that's not being illuminated by the sun, as they explain, but you can still see it. And the explanation they give is that because this is due to sunlight that is actually hitting the Earth and bouncing off the Earth, and then reflecting back to the shadow side of the moon, and then reflecting again back to your eye, illuminating the entire side of the moon, or shadow side of the moon. And I guess to a lot of people that may sound reasonable, but I gotta tell you, it's just, again, one of these things that to me just seems more and more ridiculous the more I think about it. Because basically it really kind of segues into a whole nother question, which I had already thought about, but this just only emphasizes it that much more, and that is this whole issue of light reflecting off of spherical objects. And when you look at the moon itself, just even the normal explanations of the moon, why we see the moon is supposedly reflecting the light of the sun when we see a full moon or a half moon or a quarter moon, it's always a uniform amount of light from every angle of the spherical moon, supposedly spherical moon. But just stop and think about this, that according to the official explanation of Earthshine, what's happening is, so the light is coming from the sun, 93 million miles from the sun to the Earth, passing through the Earth's atmosphere, bouncing off of the the atmosphere and the ground and the oceans and the whole variety of different surfaces, and then being reflected off, going through the atmosphere again, or bouncing off the atmosphere, whichever one. I couldn't really find an explanation of exactly what the light is bouncing off of. And so that light is bouncing off of the Earth, traveling another almost 240,000 miles to the moon, bouncing off of the shadow surface of the moon, and then traveling another almost 240,000 miles back to your eye, through the Earth's atmosphere once again. And if that alone wasn't enough of a stretch, to me it's just even more ridiculous, because again, it's when you look at their little illustrations, they just make it so ridiculously simplistic. They just show like a little line representing the sunlight going from the sun to the Earth, a little line going from the Earth to the moon, and then back from the moon to the Earth, and completely just ignoring the issue of light reflecting off of a spherical object, right? And it's doing this twice in the Earthshine scenario, right? It's bouncing off of the spherical Earth and then bouncing again off the spherical moon, and every time it's doing that, it's being splayed or refracted, or whatever you want to call it, or at least it should be, but that does not seem to be it doesn't seem to be the case in anything we can observe. And it really just made me start thinking back to years ago when I was in art school, and the first classes that you take when you're taking any kind of program in an art school is, before you're drawing the human form, or painting fruit or anything like that, they start you out with just the absolute fundamental basics of light on objects. And you have to shade very simple shapes, like like cubes and cones and cylinders and spheres, right? So I actually had to shade a lot of these. I actually had to do this a lot, learning how to use an airbrush for the first time, and pencil shading and everything. And I shaded a ton of these types of spheres, actually. And so universally, every time you go to shade, the light and shadow on a sphere, there's a point on the ball where there's the most light, because that's directly perpendicular to the light source, where it's the brightest. And then there's, as you get around the edges of that, the light's diffused until it gradually kind of blurs around the sides of the sphere, and then the most shadow part is on the back side, right? Never in an art class are you going to be able to turn in a shaded sphere that is just solid light on one side and solid shadow on another. If you tried to turn that into your instructor, they would fail you. So it's just funny, because it's just such a basic universal thing. Like, you show a picture of a shaded sphere to anyone in any culture, and almost any age, and you show them a picture of that, and they would instinctively know that this is a sphere, because just due to our own experience, we all understand the properties of light falling on objects, and this indicates that you are looking at a spherical object, okay, because of the way that the light is diffused off the surface. But then you turn around and you look at the explanations given for even just the Earth itself from space. Supposedly, you always see it uniformly illuminated on the day side, from these supposed moon landing pictures of Earthrise and things allegedly from satellites, or the moon itself, like the day side of the moon. It's always uniformly bright and uniformly dark. And when you look at this Earthshine thing, you see the same bizarre phenomenon, because that whole shadow side that you can see is uniformly lit. And now, which to me only makes it even that much more problematic, because I suppose you could, if you're talking about the day side of the Earth, or the day side of the moon, the sun facing side of the moon, You could argue that it's just so bright that it looks uniform, even if it's not. But once you're talking about light that is bouncing off the really non-reflective surface of the Earth compared to something like the Moon, supposedly, it's traveling back off into bouncing off the shadow side of the Moon. You'd think you'd only see the very hazy reflection off of the side that was closest to the Earth, right? It would not be uniform. I mean, you just really should not be seeing this uniformly lit shadow side of the Moon because of light reflecting off the Earth. When you think about the angles that's required, think about the edges of that Moon, the edges of that shadow side, where the sunlight is supposedly bouncing off the Earth, hitting hitting those edges of the Moon. That's basically almost at a 90-degree angle, right? It should just glance off and just keep going out into space, but basically what you're seeing is something that is showing the properties of a disk, right? I mean, it's just bouncing off like uniformly. It just makes no sense on either side. Not to mention that this explanation of Earthshine is given towards, like I said, the crescent moon before and after the new moon. But then on the actual new moon, you don't see anything at all. Which begs the question as to why, if this Earthshine phenomenon is a real thing, why is the new moon not actually visible in the daytime sky as well? All right, why can't you see like a faint, a faint image of the entire, like a dim full moon, but it's the new moon because of Earthshine? It doesn't happen. They say the Earthshine is what comes into play during a solar eclipse, but then not during a new moon. So I don't know. It's just another one of these like bizarro world things that until you really stop and comb through it, you just accept it at face value. But it just makes no sense, because really light should not be bouncing off of two spherical objects as if they were just like perfectly placed flat, or even like dishes, like mirrors, and bouncing back to you. I mean, I'm not sure I know exactly what that means in terms of what the moon actually is doing and what's causing the phases of the moon. I did a video on the hypermoon speculation, but it's really all just speculation at this point. I mean, the bottom line is that whatever we're looking at up in the sky, I think it's pretty safe to say that we're not looking at spherical objects shining and reflecting sunlight the way the official model asserts that they are. It's so convoluted. So I don't know. Maybe there is the moon actually being occluded by some other thing, some other force of the heavens that we don't even understand. I don't know, because it definitely seems like it's almost like a semi-translucent filter is sliding over the moon. I mean, I don't know if that's even close to what it really is, but it's sure strange. So anyways, cast a shadow um, on the ground in the middle of the night, which is just crazy to me, because when you think about how bright the surface of the moon would actually have to be when you got that close to it, then personally I don't see how there would even be any like shadows on the moon at all, in terms of the footage of the lunar landers and everything, the astronauts. Even the underside of everything should be completely okay. So over the course of Thanksgiving, tried to give myself a little break and unplug from the whole flat Earth stuff for a while. I say tried to take a break because I wasn't watching any video lit up, right? If it's reflecting that much light, it'd be like walking around on a giant glow stick or something. But anyways, that's not what I came to talk about. But so I started going back and doing some more reading on the moon and moon phases, and that was something that when I was first looking into the flat Earth issue was hugely impactful to me, because there's just so much about the phases of the moon and seeing those are going online or anything, but you still can't avoid things like going outside and seeing the moon. And there was a almost full moon last week, and every time I go outside and see that and stand in the light of the full moon and see my shadow being cast on the ground, it still just amazes me now, because just how much light it would actually require to supposedly bounce from the sun off of the moon, and the moon during the day, and all the angles and everything. There's just so much weirdness in there. So if you're looking at it for the first time, that's definitely a good place to start. It's just, on your own, going and looking at what all the official explanations of the lunar cycle is, and then comparing that to what you see in the sky yourself, and seeing how much sense it makes. So I was just reading through all that again, and I stumbled across this concept